Hello, I am Pete Beamar with Battery Research and Testing, and I will be narrating this session of our stationary battery maintenance tech tips. This is tech tip number 6, boost charging individual cells or units in a string. In this tech tip, we're going to explain how to provide a boost charge to a cell or unit that is installed in a string that is in service and which cannot at that time be removed from service. All of us that perform the hands-on maintenance on these battery systems will sometimes have a cell or unit whose voltage will not come up to or stay within the ranges that the manufacturer recommends for it, even if we perform repeated equalized charges on the string. Sometimes it will come up to where it should be when on equalize and even hold there for a little while after the equalize. It will eventually drop back down to a value that is below what it's supposed to be at. Most of the time, the issue can be fixed if a boost charge is applied to just that cell or unit, and the process is a very simple one. All you need to do this is to have a charger that can be adjusted to the appropriate voltage for the number of cells that are going to be boost charged. This process is most successful when you charge the lowest number of cells possible at a time, such as a single cell or a single unit. For example, if you have two cells or units side by side that need help, you will get the best results by doing one cell or one unit at a time. Again, this requires a charger that is very adjustable. If you're going to only use it on a single lead acid cell, then you need adjustability from 2 to 2.5 volts. Or if you intend to use a charger for only 12 volt units, then you would need a charger that is adjustable from 13.2 to 15 volts. The chargers that we've been using for a number of years now are from National Railway Supply and are programmable from 1 volt to 20 volts. There are two different models that we have, which allows us to use either a maximum of 20 amp output or a maximum of 40 amp output. These work for our needs and allows us to have enough current to boost charge pretty much any size cell, and it makes it simple. There is a new model out that can go up to 40 amps and weighs about 25 pounds, which is about half of what our existing 40 amp units weigh. As we replace our older units, we're going to these because of size and weight and some other improvements they made. All you need to do is to follow the programming instructions for the charger. Then connect the leads to the individual cell or unit which you want to boost, and then start it up. The beauty of this procedure is that the overall voltage that the battery string is set at remains the same as normal. There is no change in the voltage that the attached equipment sees. The extra voltage is only applied to the cell or unit being boosted. We continue boost charging for the manufacturer's recommended time, or until you see sulfates being driven off the positive plates with vented cells, if they are indeed sulfated. Our typical maximum amount of boost is 72 to 100 hours, but we will often go for 4 or 5 days. With any cells or units, the main concern is to keep the cell or unit from getting too hot. We try to make sure the temperature does not get over 90 degrees F and prefer to keep it lower than that. With vented cells, if you perform this boost charge and the ICVs are still all over the place with very low and very high voltages, the next step needs to be measuring the plate potentials in all of the cells to determine if there is a polarization issue that is causing the wide range. Measuring plate potentials is explained in Tech Tip 21, which is using a reference electrode to measure plate potentials. With VRLA cells or units, we normally try to keep the volts per cell near or below 2.4 volts per cell. The reason for this is to minimize the amount of off-gassing. As is understood industry-wide, when cells off-gas, they are losing water content from the electrolyte, drying out. This reduction in water from VRLA cells causes a reduction in the saturation of the AGM or gel, which causes a reduction in contact between the plates and the AGM. Plus, it reduces the compression in the cells and results in premature capacity loss, also known as PCL. Dry out in VRLA batteries was and still is the primary cause of their early life failures. Premature capacity loss was the reason that we developed the IOVR Plus program so that users that had battery strings failing from this reason could have their batteries recovered and be able to use them for many more years. Although it is not called the IOVR Plus process in the IEEE 1188A 2014 document, our procedure, which we had been performing for many years before that document was written, is what guided the creation of that document. The IOVR Plus process is explained in Tech Tip number 3. Hopefully, this explanation of how to perform a boost charge on a cell or unit in service will help you understand the importance of applying a special charge to an individual cell or unit in a string before just sticking it in there, or how easy it is to do it after it is installed. If you are interested in understanding more about what we do or how we might be able to help you, please go to www.batteryresearch.com and look around. If you would like to be notified when we release a new tech tip, please go to info@batteryresearch.com and tell us to notify you when we release a new one. Or if you just have a question on a stationary battery subject, just do the same. Oh yes, if you have any experiences or pictures of unusual things that you have found, please share them with us so that all of us in this industry can benefit each other. Have a great day, stay safe, stay healthy, and thank you.